Bismillah ar-Rahman ar-Rahim. Welcome back to our course, Deep Learning for Computer Vision. We today try to finish our first part on this course, which will be as a MATLAB tutorial on image processing toolbox and computer vision toolbox, because these two toolboxes are very related to each other, and we can see that there is a sort of marriage between the two, let's say, these toolboxes. So let's jump to our tutorial that I provided you on the OneDrive for the course, and start explaining the simple MATLAB tutorial that was applied or given there. So if you open MATLAB, you get something like this, it's a window. And now if you start on the command window, you can see the command window, you can see the current folder, you can see the workspace. So far, I don't have any variable in the workspace because I'm just starting the MATLAB. And now let's go to the tutorial given to you in the folder. We call this folder as, if you see here on lecture 10, the folder is entitled as MATLAB tour on DIP NCV part 1. And if you go to the PDF file, you'll find something like this file. Here we have the first step or the MATLAB tour for the first lecture on, or let's say tutorial on MATLAB. This is tutorial number 1. So what's MATLAB? MATLAB is a technical computing environment. It's a dynamic environment for computing applications for engineers and for a very, very wide range of users in the scientific and industrial applications. It has a lot of toolboxes, and it mainly works with matrices, and it is called Matrix Laboratory. You can find a lot of toolboxes. We are concerned only with the image processing toolbox, where you can find many applications, many functions that can be performed under different titles. Like you can find geometric operations, fan transformation, rotation, reflection. You can find neighborhood and block operations, linear filtration, transforms like DCT, DFT, DWT. All these things can be found in MATLAB. Yeah, I'm not going to list all these things because the list is very long. We'll start with a simple introduction. And we can find also here the image processing, the computer vision toolbox, which is a very, very strong and very efficient toolbox that can be implemented in case of using images for 2D vision, for 3D vision, for object detection, edge detection. All these things can be done with stereo cameras, with fisheye cameras, etc. All these things can be found in the computer vision toolbox. I encourage you to go and see what are specifically the functions that can be provided by the computer vision toolbox. Now we'll start as an alphabet for for you as starting students in the field of MATLAB applications. We'll start with reading, displaying, and writing images. As first step, we need to read the image, maybe process the image, then display and see what's going on. Then we can, if we are satisfied with the output, we can write this image into maybe on a computer, or maybe to send it remotely to another, or on the cloud, or maybe some storage devices. If you go to this piece of, or this part of the MATLAB, you can start, or you may find the following functions for reading, displaying, and writing images. These are the very common commands like mfile info, mread reads the image, mwrite writes the image, and mshow displays the image. Let's start with help with printing or typing this command, help mfile info. Start with the mfile info. If we run this, we'll get some information about this help. Okay, maybe this capital letter, we can remove it. and replaced by a small letter, you can switch this from uppercase to lowercase. However, I think that it's good to have some errors here to learn from these errors. As you see here, we have, let's clean this all. I repeat it again to have a clear version here. In file info, information about the graphics file, image in general. This gives you the command functions with specific parameters that can be applied to the in-file info. You can read all these things, and you can go also to this link for more information. It gives you about the file name, file modified date, file size, format, file format version, height, width, bit depth, color type. All these things can be found in the in-file info. If we go to our function here, let's go and ask or see the documentation for sure. If you go down here, you can find this blue underlined text, documentation for in-file info. Here, if you click on it, you will open the Help Center for MATLAB, maybe on your desk or online. So this function is in-file info. It gives you information about the graphics file, and here the syntax of the command, and you can find examples here, like this one, info on this file, for example. Let's right click on this one. You can evaluate the selection, or pressing F9, or copy and paste. It's up to you. If you evaluate this one, you'll go to MATLAB and see that it has been sent here. As you see, the info can be stored in the workspace. Double click on it, you can see details about this file, its location, where it is located, the modified date, the file size, the format, JPEG, format version, nothing is specified, width 600, height 650, bit depth 24 colors, color type, true color, which means that RGB, etc. All these things can be, if we have any other application or any other information about the file, can be found in this field. You can also see this, clear the screen and repeat this function and remove the semicolon. We can display this on using without, you know that in MATLAB when you remove the semicolon, the run will be displayed on the screen, and you can see the same information that was found here in the info file or the info saved workspace parameter or variable. Okay, so this is what has been done here. If we can also do this by going to the what we see here, OpenLeft script. If you click on this OpenLeft script, you have modified the version. Okay, open this as this card. That's okay. I just need to see the original one and try to open. It has been opened here as here. Just a minute. So this gives you a script file where you can find some details about the function itself and the run part of the code that you can just right click and evaluate selection using F9. You can also see other commands that can be used regarding this topic. Okay, this has been also seen. Let's now print this one. We have already seen this these details. Let's now go to mread. Again, we can plot mread or help mread. Ctrl+C, or maybe directly clear the screen and write Ctrl+V. So help mread. Or we can go to the help center that has been opened before and print here or type mread. So this is the function that we want to see. You can see all details regarding this function, starting from let's say the syntax. You can see also the description describing what you want to see to mread file name. If you have other parameters, the extension of the file. All these topics can be, or these parameters can be added according to your taste and according to your what you want exactly to see. You can see also examples. If you print or you type mread, this function or this already a built-in image in MATLAB, and you can see this image here on the help. The same thing can be done using mread. Mread can read grayscale images. Let's go back to the tutorial. It can read different types of files like BMP, HDF, JPEG, JPG or JPEG, PCX, TIFF or TIFF, XWT. All these WD or all these can be found according to your MATLAB version and release. Now, for this is you have out of specifications here for the different types that you can do. Now let's go and try to run this code. Control C. Here, this image IMG, I stored it here. This is my image in my folder that I provided you earlier. This is the image. Okay. Now let's see what will happen if we'll apply or type this function here. Oh, this is a problem. Error using mread get full file name. So you see here, either you have to provide C, etc., or what is the location of the file name. You need to print, for example, here we have the extension of the file name. I can take it from this place. Control C, can take it to MATLAB. Of course, this is a little bit long. Okay, and here we have part 1, and we try to give the path, enter. You have already read the image. Let's clear this one. Clear I. Let's repeat for the first one. Again, we get the problem. What to do now? We can simply go to MATLAB, and you see here we have to open the folder where we have these images. Browse for folder. Let's browse. Of course, I have a lot of things here. Let's go to the lecture itself. Just a minute. Lecture 10, and we go to this subfolder. Okay, select this folder. Now we selected the folder. We can see all here. As you see here, we can see the all files that related to MATLAB or all files in this folder. Now, if we run, let's clear all this and repeat we can use the arrow up and down to change the MATLAB CEC, and we can run and see all the previous history. Now we need this one, for example. Okay, this is I. It's okay, no problem with this one. If you look at this image, this is the image. If you look at the size, you can see that it's 1080 by 1000 by 1920 by 3, unsigned integer 8. This means that grayscale or value of between 0 and 255, which is unsigned integer with 8 bits. This is very helpful to understand what's going on. Okay. Okay, we have passed this one, and we can go now for this part. Let's continue and see what is I. You can now see the OpenLive script that is related. I have just mentioned before. Here we can go to the OpenLive script, and this will open for you. No, open this file. Okay, I just need to start from beginning. And this is the file will be appearing in the live script with details about the help and what function to be run. For example, let's run this one and apply, select run the selection. If we go to the MATLAB, we can see that we have a matrix. If we try to see what is the content of the matrix, it cannot be displayed because a three layered image, three-dimensional or RGB image. It's not a matrix, it's a three layered matrix. Okay. Let's continue. We can go now and start with, we try to show or to see the image. This can display for you the image with a lot of parameters here. You can see it later on and make your work, your exercise on these things. Let's go and now ask or try to run this one, show for img4 JPEG. This image is already stored in the file or the folder that I told you before. Show img JPEG 4. Again, we have some problem. Explain. Okay. Let's try to show I that is already stored here. Show I. Of course, we have already loaded this image into our workspace, and the image will appear inside MATLAB this way. This is our image that we have already seen before. Okay. Try to solve the problem with MShow directly. How we can modify this to get for IMG4. Now this, we'll try to read the image first, to read the image first, then apply MShow, then give it a title, to give it a title. Let's copy this code. You can do it on your own because the PDF file can be is editable. You can modify and use your. Again, we have here a problem with. Okay, let's open again the file. I think we have skipped the file here. Let's go to this lecture where we have stored all this data. Select folder and repeat the process. Okay, now it's okay. This is our image, and it has this is the image. You can see it in a large scale or on a small scale with its own title. Now we can repeat this for you see here we have different options for MShow. You can show sub ranges or sub specific, let's say, range of pixel values between 20 and 60, and for example between 100 and 120. And now I have opened figures, different figures to show separately each part of this image. Let's go and see this. Let's run this part, screen all this. Okay, you see, this is the original image. This one is the range for, again, the original but repeated here from previous example. Here for the range between 20 and 60. So we try to make 20 down to 0 and 60 up to 100, up to 255, which is the full scale. And this one for 100 to 120, we have it as the 100 is black and 120 is the white. So we try to rescale the grayscale version of the image. And now we have a lot of images opened. We'll try to close all these images, close all these images, and type this one. And we can clear the screen, clear CLC, can clear the screen for next operation. For mWrite, we can read the image, for example, mRead, and write. We have already an image I. We can write it in another format. To do this, we need to go and type help in MATLAB on mWrite. For example, here mWrite. What is mWrite? It's a function that can be used for image write, mWrite. So we have here the syntax, we have description, details on the mWrite function, and we have also examples to write grayscale images, to write different types of images, grayscale, colored. As here, very important to remind you with the indexed images, because we have here the notation of palette, and the index X and the palette map. We'll talk about this later on. Anyway, you can now open the script and see what you can do using these commands. Now, let's try to save. For example, I have the image A, or maybe I. Let's copy the code, write, Ctrl C, and Ctrl V. Suppose that we want to write the image I into another image, let's say A, with an extension BMP. The original image was maybe JPEG or maybe another format. Let's say PNG. We'll try if I don't know if we have PNG or not. We'll see. Okay, the image I has been written into a file AA PNG. This is the file here. Let's go to the folder where we have our images AA. We'll try to see where is this. This is the AA. Double click on it. We have the same image has been written this way. Okay. This is for MWrite. Let's go now again to our tutorial. In MATLAB also we can write the DICOM format, can read. We can get info, we can read, we can write, and have some text containing the DICOM details about the file. I encourage you to read some details about, because the DICOM format is a very rich format. It's a meta file that contains text and images, maybe more than one image, maybe different slices for medical applications. Now let's play with the image for types and formats. You can type there to know what are the toolboxes that are installed on your system, just for your check. Now you can select specific location, a specific pixel from the image I, Ctrl C, just a minute, okay. Let's write this one, C, Ctrl V. You see that this is the pixel value is at location 215 is 225. Let's go to I and see if we can open it, because it's a two-dimensional array. Here we have the whole image. You see here we have all these gray level values starting from 112. The last, let's have last pixel. This one is the last pixel, having the size of 469 rows by 531 columns. So you can look for, you can also modify here, can let's try to delete all these values. Okay. Now this modification has been let's say saved. If we try to mshow I after modification, we'll try to see whether we have already stored this part. You can check for this place. I don't know if you can see it or not. I'll try to zoom it for you. It's a very small piece of the file. I'll try to zoom it for you. Possible? I'll try to zoom if possible in tools. Zoom out. Let's try to zoom out here to zoom in. Okay. I think it's clear here, no? You see this small black square? This is what we have modified and put it or set it to 0. So you can play with these details and change and have this modification. Let's go now to playing with color images and formats. In general, in MATLAB, we store the color image as 3-layered image, R, G, and B. For example, in our case here, AA image or a image that has been stored before. Here we have A. You see, you have 3 layers of grayscale images, grayscale for red, for green, and for blue. We may sometimes store the image in the form of indexed image. Here we have the indices in the image with the lookup table. As you see here we have the indices taken from the image, and here we have the lookup table used to depict the grayscale, the colored image in form of indexed image. Okay, we'll show some examples below. We have also different file formats that can be converted to. Here we have, for example, RGB2 HSV, RGB2 NTSC, it's an American standard, RGB2 YCVCR that we have discussed in lectures, etc. All these can be done forward and inverse. For example, if we have RGB to HSV, we can find HSV to RGB. If we have RGB to indexed, we can invert index to RGB. So the conversion can be done forward and inverse. Let's have an example or some examples on this. Here we have an image IMG3 stored on our folder. Now we want to convert this into RGB to HSV, hue, saturation, and value. It's a format, well-known format, and we give it a title, specific proper title. Then now we try to find I2 that has been obtained using the RGB HSV, and we will try to depict and see what will happen. Here we have some comments in the code. Let's clean this. Sorry. Escape CLC. Let's print this one. Here, this is the original image. Okay, let's have a look on this. This is the original RGB image. We have converted the image into HSV scale. What is this? Why we have modified values and different something different than what we have in the grayscale version? I will just remind you or make you remember that in the hue, saturation, and value, the range of pixels, hue is the angle, saturation is the percentage of the colorfulness of the in the pixel, and the value is the grayscale. So if you depict it as is, you will get some different image type, because we have here not the original RGB. Instead, we have a modified version of the image. Okay. Here we have a very good image. We'll try to separate these colors. We have green, red, green, and blue. We'll try to separate each pixel. We have some details here about dithering and other things. Here, this image is image IMG JPEG, and we now try to convert it into grayscale and to indexed. Here, you have to read or read the image I, which is the RGB image. Now convert this image into indexed image by having the output as the indices, the grayscale version from 0 to 255 maybe, because we have here 256 colors. You can type help on RGB to index to get some info about the command, this command line or this command function. Apply it to I, get the index image and the color palette in terms of what we call it the map in MATLAB. Now we use another sort of indexed images, but this time with, instead of 256, we take just 32 colors, and finally we take just 2 colors, not just for just to compare when we reduce the size of the map, what will happen to the image. Here we get a figure and apply. We try to find the sub image I, index 1, index 2, index 3 that we have already run at this place, and we use the what we call subplot. This divides the figure into sub figures of the size 2 by 2. Then we take the first quarter, second quarter, fourth quarter, third quarter, and fourth quarter. I encourage you to have some help on subplot to get more info or to understand what's going on here. We'll copy this code and run it in MATLAB, CLC, Control V, and we'll see what will happen now. Here we have this image. As you see here, it's enlarged a little bit. Okay. If you have a look on these images, with here we have the subtitles. Here, this is the original image at the corner. Okay, this one is the original image. Here we have the image after being converted into indexed with 8 bits only per pixel instead of 24 bits. Of course, we used the indices and the map or the lookup table or the palette. Here we used only 32 bits, 32 colors or 5 bits, okay, bits per pixel. Here we have just 2 indices, and the lookup table contains only one of 2 values, either 0 or 1, or black or white, and this is what we could achieve. And for sure, when we reduce the number of colors in the color palette, the quality will be reduced. Sometimes we may reach a compromise solution and get a good image even at low bit rates. This is the same image. Here we can obtain images again using the YCBCR, color format, HSV, or YIQ. This can be done again using the modification or changing the format according to our application. This is for the color images. Now, if we have grayscale images, we can, if we type help on grayscale images in mathworks.com, you can find many operations that can be applied to grayscale images. You can convert image from RGB to grayscale. You can convert indexed image to grayscale. You can convert a matrix to grayscale. All these commands can be found in MATLAB. Here I provided you with a simple code to get a gradually changing color from dark to white, or from black to white. And in this case, it's my very simple code. Let's try to run this code, okay, and see what will happen if we run it in MATLAB. I encourage you to study this code. This is the image after being converted to from matrix to, it's a matrix containing values between let's say dark to or black to white, and it has been converted into by matrix to gray into a grayscale image. Here we can do this again. Here we create a 200-point cosine wave and convert it into image to see the variation that can be seen using image processing or image toolbox. For example, this one is a cosine wave. I see here we have the value. It was just starting from white, dark, then again back to white. We demonstrated this one using two-dimensional grayscale image using the matrix to gray application. This is sometimes very useful for your demo. If you look at it, it's not very meaningful for image processing by itself. Now we have some image stored in MATLAB con.tif, and want now to read this image as grayscale as indexed image. We show it as indexed, then we try to convert it into RGB by applying the command function in index to RGB, and find here this code I again encourage you to see what is display code and what are these things here inside the code. It may take some time for me to explain it, so I'll leave it for you and hope that you will enjoy working with this. Let's see this one. Here, this is a popcorn with different colors. This is the image. Let's see the code. Okay, this image has been read as XMAP. It was converted again from index to RGB and displayed using this thing. And here you see here the output is range of RGB is between these two values. For sure here normalized. The value of 1 means 255 and 0 means 0. And in between you can take the normalized values for the grayscale version. In this case, grayscale version for R, for G, and for B. You can again type index to RGB and go to the OpenLive script and see all these things. Finally, we may talk about the binary images. Here we have either black or white, either 1 or 0. Again, this is a categorical variable. 0 means 0 and 1 means white, 255. You can apply many operations for binary. You can convert a grayscale image into binary by using image to binary, black and white. You can use also binarize. It can be used to convert the grayscale image into or 3D even volume images into by using thresholding. Above threshold means 1 or white. Below threshold means 0 or black. You can print or you can type binarize to see this. Let's take this and try to have some help. Yes, help. You see, MATLAB is helping you to take these details are regarding the how to apply the thresholding or the binarization by talking about what do you want to binarize if you want to add a specific method or a specific threshold. All these things can be found in this help. You can go again to the documentation by clicking on the binarize here. You can find here details about it, and you can open the live script to see what is related to, and you can see some examples and run it when you apply binarize in this case. You can find a lot of examples on these in these tutorials and find out, and you see here how we can improve the quality of the image by applying binarize with selecting specific threshold with some additional information about the foreground, background, and the sensitivity of the exposure of this image. I encourage you again to have some look on these details. Very useful and very efficient in the field of image processing. Here we have some simple example on binarize. We try to select maybe the first example. We have. I think that we don't need to go back to binarize or into BW. Let's start. I'll try to convert the image to BW. I don't know if it works or not for I, which is a colored image. I think it's okay. Now I'll see type figure show BW, which is the output black and white image, and see what we have here. Let's see what is I here. Figure again show I. Okay, this is I. I'll try now to reload I, which is what was read JPEG for example, this one, and repeat show I. This is my grayscale image. Now I'll try to apply binarize to this image and show not I, instead I want to show BW. You see here, MATLAB has selected its own threshold and binarized the image into black and white. Now let's have another example. Let's take A, which was no, this one, not A. I think it was. Let's have a look on this. Do we have yeah, A capital? So let's be BW and binarize this A capital. It's okay. Now figure BW. This image was what we previously loaded. You see that the quality is not very high. We need to work to do more to select the proper threshold for converting the image from RGB or from grayscale to, let's say, binary image. Okay. I have also loaded a file, some functions into MATLAB. Let's go to this folder. We have here split RGB open. It's a function. You can do not script files only, can do also functions. This function takes the file name and split it into RGB. From RGB to I mean from RGB to red, green, and blue component. Here you have to take care with this, because when you want to show a red color, you need to put the blue and green as 0. The same thing for G, for B. So let's run this code. Split RGB for the image JPEG IMG7. Control Z, Control C. Let's go to MATLAB and clear this and Control V. Okay, you see here we have the image being splitted into red, blue, green, and blue components. If you go back to the function, here you need to, as here we have here RGB double. This is very important to convert the range between 0 and 1. And R equals zeros of the size RGB. So the size of R, if we look at the R component size, I think it will be not clear here because it is inside the function. Okay, we may write this inside the function. Let's have this one, size R, and run it again, save, then run it again. Okay, we'll get this value. So the R component contains 3 layers, here 3 layers. Both the G and B are 0, while R is taken from the original IMG7. Okay. I also included a simple graphical user interface for MATLAB. Simple, very starting just, and I included the files. You can have a look on these files. If we'll type this GUI intro, we'll get some, let's say, graphical user interface, simple for getting or dealing with images. Here you have to, we here have a sub window. Having pick an image, we can select from a scroll image. Let's take, for example, IMG2. This is a MATLAB image. Let's take, for example, IMG7, this image that has been displayed before. Let's take IMG8. Now, this gives you the information about the file size. It's an RGB image, and this displays for you the image here just for demo. If you are finished with the work, you can close the session. You can also add other functions, other buttons, other types of bars, scroll bars, pop-up menus. All these things can be added very easily in MATLAB, either as graphical user interface or as by writing the code. When you close the session, you'll get out and get out of the file. Finally, I think it's okay to have a look on these details. because it will be included in the first exam. And I hope that you enjoyed this tutorial, and see you soon